Welcome to the Clean Energy Revolution. I'm Carolyn and I'm an Associate Dean at New York University's Center for Global Affairs. Coming up on the podcast today, we'll hear about some key technologies that are working to solve the biggest issues we have in the deployment of clean energy. What innovations are speeding up progress as we move towards net zero? Without the growing deployment of 5 key clean energy technologies, solar PV, wind, nuclear, heat pumps, and EVs, the growth in emissions between 2019 and 2023 would have been 3 times larger than it actually was. The transition to clean energy is the biggest challenge of our generation. Decarbonizing the world's energy will require transformation across its infrastructure, supply chains, and the technology it uses. This is completely new territory, and as a result, we need totally new ways of thinking to solve the problem. This means the industry must continue to innovate to drive this change at the speed and scale needed. So what exactly is needed, and how do we speed things up? My co-host Laura, also known as Less Waste Laura, was in London at National Grid's Innovation Day, and she'll be bringing you more fascinating conversations from leaders and companies who are innovating to accelerate the clean energy transition. That's all coming up later in the show. First up, though, I want to talk a bit about the global race for artificial intelligence. I wrote a piece recently for Barron's where I talked about the impact AI is having on many emissions goals. Data centers use a lot of energy. Tech giants like Google and Microsoft are well aware of this problem. They were early adopters of net zero pledges, but need to make sure they balance emissions goals with the rising power needs of AI infrastructure. Google's carbon emissions increased by 48% over the past 5 years, largely due to AI compute demands. We wanted to hear what they're doing about it. Laura caught up with Neil Osborne from Google at Innovation Day, and he talked through some of the innovations they're making to tackle this challenge. Let's hear a bit of that conversation. Laura, over to you.
Google is definitely a household name, but what on earth do they have to do with energy? Well, I bumped into Neil Osborne, who is the Chief Energy Evangelist at Google, and he shared a lot of information about the innovation happening with Google. They are a huge energy user, but also they have amazing technology with AI and other advancements that they are able to share and collaborate with the energy sector. Here's what he had to say while we caught up. And you have maybe one of the most interesting job titles I've come across. Your title is Chief Energy Evangelist. Tell me a bit more about that.
Yes, Chief Energy Evangelist. Well, look, I didn't come up with the title. It was bestowed upon me by my colleagues as a bit of a joke.
Okay.
And it stuck. But essentially, evangelist is kind of what it is. You know, the role is to evangelize about, what Google can do to help utility companies in the energy industry. So, a large part of my role is talking, at events like this and so forth, and just getting that conversation started.
And today we are, of course, at Innovation Day. What are some of your main aims, coming to an event like this?
Well, it's to show that, we are here and we are interested in helping solve the big problems, where we can. I've just come off stage, where we were talking about some of the challenges and so forth, and what are the technologies that are going to help, on our journey to net zero. I'm under no illusion that technology isn't going to solve the problem, but it is going to help enable us to do things better. And so attending events like this is all about passing on that message and getting engagement, because one of the other key messages that I gave was around collaboration and sharing. We can't do this on our own. We've all got a vested interest in moving to net zero, and by collaborating, by sharing information, we can help accelerate that.
And I think one of the things that has been spoken a lot about today, buzzwords like AI, for example, and if somebody said, who do you associate with AI? Google's probably one of the companies you might mention. How does AI, Google integrate with the energy sector, which isn't maybe a sector that would jump to mind when you hear those buzzwords?
Well, I suppose it starts with the fact that we use a lot of electricity. So we use huge amounts. And so we have a responsibility to use it efficiently and wisely. And therefore, we start to deploy our own technology, AI, to help us make our data centers more efficient and so forth. And then we begin to share that with our customers. One example I gave this afternoon was that you have these things called workloads. You imagine a piece of work you have being done by a computer in a data center somewhere in the world. Well, in Google Cloud, you can move that workload to a data center which is sat on a grid where renewables are more abundant at any point in time. So you can actually proactively move stuff around to make sure you're making best use of renewables where they exist.
And I think that's really nice to hear as a kind of consumer of different products. I've got my Google Calendar, I do lots of things on documents, emails, and it is good to know that something that I might not have much control of, actually you are innovating for me to make sure that that impact is there. You have been sitting through lots of talks today and there's been lots of discussions. Is there anything on the horizon that you have just been feeling is a great innovation that's coming, or something that excites you when we talk about the big things like the grid, net zero, AI, things that we are talking about here?
The wider adoption of AI, I find very exciting. And we are taking baby steps towards it. The industry is very cautious for very good reason. And last week I was up in Manchester University at a conference where they were talking about cybersecurity. And some of the innovations, some of the technologies they're now using to keep information safe and will allow us access to the data in a safe and secure way. Those really excite me because they will open up huge amounts of information and enable us to do some of the things I talked about on stage, helping optimize grids and wind farms and solar farms and so forth.
Wow, I think that's just really insightful to hear a little bit of how that collaboration is happening with an institution like Google, being able to share that knowledge when we think about the energy sector. So thank you so much, Neil, for your time, and I hope you enjoy the rest of Innovation Day.
You're very welcome. Thank you very much.
Tech companies use a lot of energy, but they're also at the forefront of developing solutions for energy use. The next energy breakthroughs may come from the same tech companies whose AI data centers are currently contributing to higher carbon emissions. Now, onto an innovation that is making a real impact on energy efficiency: dynamic line rating, or DLR. Technology is already helping National Grid to lock up to 40% extra capacity for electricity to flow safely through their power lines, in collaboration with DLR operator Line Vision. Unlike static line ratings that are based on conservative fixed assumptions about weather and line conditions, DLR systems use real-time data such as temperature and wind speed to determine the actual capacity of power lines. This allows operators to safely increase transmission capacity when favorable weather are present. Laura sat down with Alex Houtailing from Line Vision to learn more about the technology and how dynamic line ratings are an innovation in clean energy that's making a difference to consumers like you and me.
Dynamic line rating is something that you will hear a lot about when talking about innovation in the energy sector. It is the way that we make the most efficient decisions based on how electricity travels through the grid. And it was great to be joined by Alex Houtailing from Line Vision, who was able to talk about this technology that is now being implemented in many different places so that we can see innovation and efficiency throughout the grid. Here is a little bit of our conversation we had on Innovation Day with National Grid. Technology, when it comes to innovation, has a huge part in this, and you have a very interesting type of technology, dynamic line rating, which lots of people today have been talking about. It seems like a buzz technology. Could you just share a little bit about what actually is that technology and what challenge is it addressing?
Sure. You sometimes find companies that create a solution and then they go try to find a problem. And we have technology that is relevant and is addressing some of the biggest challenges that are facing the utility industry today. So we're very fortunate in the sense that we're incredibly well positioned to deliver a lot of positive change. some of the biggest challenges that utilities face center around demand growth. So more electrons being needed. And for decades, that has not been a challenge. And that's largely due to energy efficiency programs where we haven't seen demand growth. But that's very much changing with things like AI, where you have much thirstier data centers for electrons. You have a situation where generation now is distributed. So in the past, you would have a load center, a city, and a mile down the road, you would have a generation facility, and that worked. But now there are electrons coming from the ocean with offshore wind. There are electrons coming from the desert with solar farms. And so the grid that exists today was never built to accommodate this generation in lots of different areas where it was never designed to be. So those are some of the challenges that we address. And we do that effectively by giving utilities visibility into their existing grid. And you mentioned dynamic line readings. That's a perfect example where that visibility allows them to understand how much more power they can put on the grid. So for existing lines or new lines, making sure that you are utilizing those to their fullest potential. So you are able to serve those data centers. You're able to onshore, offshore wind and get the lowest cost, greenest energy to consumers.
Yeah, and I think we've been painting a picture on the podcast so far, just trying to get everyone to really understand what this looks like. And there's the classic example where we talk about the energy infrastructure like roads. And absolutely, the sort of old way of looking at it would be big fossil fuel based energy, big trunk roads, and it was quite simplistic. But as you've mentioned, we now have a very complex, a very diverse, dynamic range of places that we're getting energy from, but we're also getting lots of users and lots of things are now being electrified. So there's this huge amount of demand and huge amount of capacity. And your technology helps us navigate that just a bit more. What role does this technology and this innovation have when we think about net zero? Because that is obviously the big goals that lots of businesses, companies, but also countries have.
Well, it's a good question because that is a challenge that's being taken on by utilities because their customers demand it. And a lot of that, like I said, has to do with generation. So if you're able to create electrons that are green offshore or even onshore wind or solar farms, you need to be able to get that power where it's going to be used. And you need space to generate energy. I mean, you can have distributed generation on rooftops, and that's a really important thing. But when we think about this at the utility scale, it is placing generation potentially hundreds of miles away from where it's ultimately used. And so you need a better electron highway to get that green energy where it's utilized. And you do see a lot of companies driving that innovation where data centers, for example, demand green power. And so in my world, I've seen a lot of positive change happening from that demand, but ultimately it's an economic story. And the lowest cost energy is typically the greenest energy, and that is pretty new. That hasn't always been the case, but now that it is, we have a social and moral responsibility to be able to utilize that, and you can't do it with what exists today.
Absolutely. And this technology that you've developed is now being implemented in many different places. I recently saw that New York has taken this on. How has that been for that city that is now utilizing this to help them with their grid?
New York State is a really perfect example of this energy transition because if you look at the physical shape of New York, you can almost liken it to a funnel where you have a lot of wind generation in Western New York, where I grew up. You have a lot of generation in the north, and then you have actually quite a bit of hydro that comes down from Quebec. And so all of those green electrons need to funnel their way down to the load center, which is New York City. And you can't do that, again, if you have a grid that wasn't designed to handle that much power. Now, one option is to build more transmission capacity in the traditional way with poles and wires. And that is needed. We need more transmission in this country, but it's really tricky to do that because, well, of a whole lot of things. The ability to site new transmission, to permit new transmission. And I know there's a lot of effort being done to accelerate that process, but it's still slow. And one of the virtues of grid enhancing technologies, which is the broad category where Line Vision fits in, is that we're able to deploy very quickly, and we can be a bridge to that new transmission system. But we're also able to ensure that you're getting the most out of what you have. And in many instances, that can allow more green energy to reach, in this case, New York City, within 3 months. So from the time that we agree to work with somebody like National Grid to the point where that additional capacity is available is about 3 months. So this is fast.
And it's great to see a technology that utilizes what we have, recognizes we need more infrastructure, absolutely, but there's actually a better way of moving that energy around. And we are, of course, having this conversation at Innovation Day here in London. Is there anything that you have heard today or anything that you've just seen on the horizon when it comes to this space of innovation, tech, AI, that just really excites you about what's to come for the energy sector as a whole?
Typically, when I've attended conferences focused on innovation, everyone is patting themselves on the back for doing something new and creative. And while that spirit is important and healthy, and there are many reasons to celebrate, I think taking a much more sober approach to innovation and recognizing that innovation is not just cool technology. That's part of it. Real innovation can only happen if you have an organization that's structured culturally and from a functional standpoint of welcoming new innovation and adopting it. And one of the points I made earlier was that within National Grid, one of the people who made the biggest difference for us is a person named Ken Buskey, who controls the control center in Syracuse, New York. And I bring him up because he's somebody who is the ultimate end user of greater capacity on the grid. He needs his team to be able to have more operational flexibility and control. And so what's most invigorating for me being here today is recognizing that people are willing to look at themselves hard in the mirror. We need to change ourselves to be able to bring forward these types of technologies.
Well, I think that's just, really insightful to know that it is not just about the cool tech, but actually it's the people and understanding the great need that we have, and also that moral responsibility that we need to do this, not just because we want to make efficient grids and efficient energy, but actually we need to be tackling net zero and climate change. Thank you so much, Alex, for coming on the podcast, and I hope you have a great rest of your day at Innovation Day here in London.
Thank you. It was a pleasure. Thanks very much.
Yes, its energy demands are high, but at the same time, AI is transforming how we monitor and manage the grid. AI systems are used to analyze grid infrastructure. In the UK, this includes 300 substations and 22,000 overhead line towers, and identify where maintenance is needed. Usually, maintenance is done by drone or helicopter, but smart monitoring systems are reducing the need for manual inspections. What about reducing bottlenecks on the grid? How does AI help there? To find out, Laura was joined by Gary Stockdale. He's a net zero innovation manager at National Grid. Let's hear some more about the cool new tech he's overseeing.
Two words that might come to mind when you think about innovation are drones and AI, and that is something that I was thrilled to talk about with Gary Stockdale, who is the Net Zero Innovation Manager at National Grid. He was talking about some of the technological advances that they are pursuing in the space of innovation and net zero, and it includes drones and AI. So make sure you listen close to what he's got to say. Welcome to the podcast.
Thank you very much. Yeah, great to be here.
Now, your title has all the buzzwords in it. I would just love to hear a little bit about what your role is. What does a net zero innovation manager do?
Sure, it is a nice job title. I do like it. So my role, I work in National Grid electricity transmission. So we do the motorways of electricity across the country, if you want to see it like that. And the team I've got do innovation across everything we do in transmission, essentially. So if you think about our infrastructure, the substations we've got, the overhead lines we've got, the underground cables we've got, very complex stuff around like grid stability, that kind of thing. We do climate innovation, so how are we adapting to like climate change and what impact does that have on our infrastructure, cyber innovation, so all sorts across the spectrum really of what we do in transmission. And
today we are in London at Innovation Day. How do you see innovation playing a role when it comes to us reaching net zero, that big goal that many businesses and countries have for their emissions?
So I think innovation is really critical, and that's not just me being biased because I'm Net Zero Innovation Manager. But so innovation has the potential to accelerate net zero. So if we can use technologies, for example, to get more capacity on the grid, there's also, I guess, if you take a step back and look at some of the bigger picture, climate change is a problem that humanity needs to deal with, and it also impacts the assets that we've got. So you need innovation, and it's critical in how we can kind of predict and look at how climate change is going to impact that infrastructure and those assets that we've got, and how can we manage that and mitigate that and design that into our future thinking. So lots of reasons. I think that bigger picture really is how can we use innovation to kind of accelerate that mission to net zero, essentially, and how can we use innovation to do things more efficiently or quicker or cheaper or smarter. It's not always easy. Sometimes innovation takes time. It might be more expensive to start off with, or we got challenges along the way, but it absolutely has a role to play, I think, in how we can get to net zero.
Amazing. Can you paint a picture? What are some of the projects? What does it look like on the ground when you're thinking about the innovation within that transmission space?
So some of the things we're looking at, one of the ones I particularly like because it uses AI, which I know is a bit of a focus for the world at the moment, as we've got ChatGPT and Gemini and all these tools coming out, and the world is talking about it. But one in particular is looking at how we use AI to analyse and get through I guess more throughput of condition assessment for a lot of the infrastructure that we've got. So if you think National Grid Transmission has around 300-ish substations across the country, about 22,000 towers, so the overhead line towers that you see across the UK, so a lot of infrastructure. And as we go into net zero, there's going to be lots more of that in different size and scale. So we're using AI to analyse images of that infrastructure, and it can then help give us informed information around like what's the condition of that infrastructure. Does it need maintenance? Does it need replacing? Like we clean towers, not a job for me, I might add. I would not want to get up on top of a tower, but we do have people that will paint and clean towers. So it kind of helps us understand the picture of our infrastructure, and that AI is trained on lots of images and will then essentially allow us to get more throughput of condition monitoring is one example. We've also got technologies that are helping with capacity on the grid. So one of those, I like to use the analogy of like a GPS. If you imagine like you're driving through London, where we are today, and it gets busy in London, right? So sometimes your GPS will reroute you a different route to get there quicker. We've got innovations that do the same on our infrastructure. So it helps reduce bottlenecks across the boundaries that we've got on our transmission system, and it will help autonomously reroute and help us, move electricity north to south essentially in the country and free up capacity. So we've got things like that. Loads of stuff. I could go on. There's lots more. But yeah, maybe those are two good examples to use today.
Well, Gary, thank you so much for coming on the podcast. It's just actually really helpful to visualise what it means when we talk about innovation and net zero. So thank you very much, and enjoy the rest of your day at Innovation Day.
Energy storage safety has become a major focus in the push for cleaner energy solutions, especially with the ubiquitous use of lithium-ion batteries. Historically, concerns about fire risks from lower quality lithium-ion batteries have dominated the conversation, but recent innovations are changing the landscape. A fail-safe lithium-ion battery system that operates safely is a major recent innovation. Laura caught up with Eric Stein from Viridi to hear about how the systems they use to improve battery safety. I won't spoil anything, but I will say the technology was originally developed for NASA, so it's pretty fascinating stuff. Have a listen.
When you think about lithium batteries, some of you might jump to the fire risk. It's something that has been in the news a lot. But there is technology, particularly in the energy sector, to try and combat this. I was joined by Eric Stein, who has absolutely pioneered in this space of making safe battery storage that is something that's absolutely crucial for us to reach net zero. Here is a little bit of our conversation while we were at Innovation Day. Welcome to the podcast.
Thanks for having me.
Today is all about innovation, and we are talking about all sorts of innovation to do with new technologies, new policies, communities. Where do you slot into that innovation sphere within the energy sector?
We've developed an architecture for lithium-ion energy storage systems at a commercial scale to be placed behind the meter. So the benefit of that is if you can take lithium-ion energy storage systems and keep them from catching on fire, which is a key risk that many systems have, you have a really interesting opportunity to help innovate the grid. And by having a fail-safe system that can go in commercial buildings or in residential homes, you can effectively almost double the capacity of the grid, because you can charge at night when the grid is off peak, and you can discharge during the day when it's at peak. So it's a really interesting architecture that we're seeing a lot of traction on.
And it's not just an interesting piece of innovation, but actually I feel amongst just regular communities, everyday end users, things like lithium batteries and the fire risk can be quite scary. You know, you almost think there's a lot of, news stories that have been out about dodgy lithium batteries. How much is this reassuring sort of end users in the safety of this infrastructure?
Well, it's reassuring them to a significant degree. I think, the lithium-ion storage sector has gotten a little bit of a bad rap because of the scooters and the different things that have caught on fire, and rightfully so. They've created significant issues for many people's lives. Those batteries tend to be, on the cheaper side, imported, lower quality batteries that are causing those issues. We use a really high quality cell to start with, but then our architecture around it keeps the system safe to the extent any one cell could go into thermal runaway. That's a rare event with the quality cell we use, but if it does, you can't afford the risk. If you're going to be inside a building like this in a home, obviously, you can't afford to have a risk of fire. And so we eliminate that risk, and it creates a significant opportunity for people's lives and the homes to be able to save money on their electricity. And it also creates a real opportunity for the grid.
Yeah, and I think it's huge because when lithium-ion batteries really started to get into the news, I was taken back to when I was at school and we got brought out some lithium, and it was in a little jar but with some oil, and the teacher said, okay, I'm going to take some of this, I'm going to drop it into a beaker of water and let's just see what happens. And of course, fizz bang, wallop, you see that chemical reaction, and that really stuck in my mind.
Yeah.
But lithium batteries, as you say, we've kind of integrated them into everyday life, but it's good to know there's a distinction between the lithium batteries that are getting a bad rep and that are in these kind of dodgy items and the energy storage. That's really important. In terms of battery storage, where does that fit into our goals to reach net zero? How important is it that we also have energy storage alongside green and clean electricity from wind turbines and solar panels?
And to really solve the whole energy transition problem, or to really drive it to I don't know if you ever get to a conclusion, but to really drive it forward, you really need everything. You can't just solve it with energy storage. You can't solve it with technologies that make the lines more efficient. You need the whole, all of it. And so I would differentiate what we do, which is obviously energy storage, from energy storage in front of the meter or at the substation level or upstream. There's a lot of technologies and deployment that have been going at the upstream level or at the substation level, which has been really impactful, being able to capture intermittent energy that's being generated at the generation level. But there really hasn't been significant scale yet behind the meter, where you have mass deployment into the home and into the commercial and industrial building landscape. And when you can do that, you can create gigawatts of incremental efficiency by deploying it. But the trick is you've got to be energy dense, because real estate and the footprint of both a commercial building and in your home is at a premium. So you have to be really energy dense, and you have to be safe, as we've talked about. And you can't be kind of safe or sort of safe, or, well, we're pretty safe, or we're a little bit safer than the electric scooter that's in your house. You actually have to be fail-safe, and that's what we developed. And so we think it's pretty revolutionary, and we think there's just a massive, massive market globally, but particularly in the U.S. and in the U.K.
And I think that really hits the nail on the head also with when we think about innovation, it's not also just about the tech, it's actually innovation of thought. We've had an energy system that for decades, centuries has been a one fuel thing. It's fossil fuels, it comes from one source and we use it in basically just a few ways. Whereas actually the green, clean energy revolution involves a lot more diversity of where we get our energy from, how we use it, who are the consumers, but also how we store it. And it's just exciting actually to hear about this.
Yeah, it is exciting and it's totally new and different. And I think there's going to be more and more transparency about where you get your energy day to day, where a building or a company gets their energy on a day to day basis. There's so much more transparency on where that comes from. And you can do things in the not too distant future when coupled with technologies like ours, where you can charge when you know power is clean and you can discharge when you know power is dirty. That's really more difficult to do today. But tomorrow that's going to be a pretty easy thing to do. And with our system, we can algorithmically program it, if it's, for example, connected to solar, to look at the weather patterns, look at your usage patterns, and effectively dynamically charge and discharge based on those patterns, based on when energy is clean, based on when it's dirty, based on in certain jurisdictions in the U.S., you'll see massive spikes in power costs over the course of a 15-minute period. So when the system detects that, you discharge your battery to avoid those big peak expenses. So we're really excited about it. We think the evolution of all of the different diversity in technologies is going to play to our benefit, and we hope to be a small part of that.
Yeah, and I think that's really crucial. It's that, for us, it's halftime at the football, or for you, it's the Super Bowl halftime show. Everyone's going and plugging in their kettle or whatever it might be. But also it's challenging. What's been a big barrier to renewables, which is, well, what happens when the wind isn't blowing and the sun isn't shining? Actually, here is a way that we can be combating that, because we've stored this amazing energy from renewables and we can put it out when that might be in shortage. So thank you so much, Eric, for joining us on the podcast and sharing about your little slice of innovation in this sector.
Thanks for having me.
Finally, let's talk about conductors. Traditional conductors, designed over 100 years ago, use hard aluminum for strength, but have limitations in conductivity and heat tolerance. They sag when they get too hot. This creates issues in grid capacity. If we can improve the efficiency and capacity of conductors, we could make huge progress. Jason Huang is president and CEO at TS Conductors. They've developed a smart conductor that can measure temperature and sag in real time, helping utilities optimize grid performance and improve capacity. How do they work? Let's join Laura and Jason to find out.
When you think about innovation, you might not jump to conductors, because for about 100 years, the technology has not changed. But luckily today, I got to sit down with Jason Huang from TS Conductor to hear about the world debut of their smart conductors that are really powering innovation when it comes to making our grid the most efficient that it can be. Hear a little bit of what he had to say. So Jason, how are conductors being innovated?
Yeah, it's really material science. When you look at conductors, the conductors are built with conductive elements and also a strength member that supports the conducting elements. And 100 years ago, when ACSR was developed, which was the conductor that is still dominant in our industry today, it was just simply taking advantage of what is available at the time. High-strength steel at the time wasn't that high strength. So they actually had to use aluminum that is hard aluminum. It doesn't have the best electrical conductivity. However, it has some very good mechanical strengths. And the industry was leveraging the hard aluminum strengths so that the conductor has adequate strengths. But it did compromise on a few things. One, conductivity or ampacity. At the same time, there's a temperature limit. It cannot go above 93 degrees. If you do that, the aluminum starts to anneal and then you lose strength. So that created the constraint. And this is also why we have a bottleneck in our grid, that you cannot run these traditional conductor hot because they're going to sag excessively.
And I think it's really important to not only recognize that there's been challenges so far, but actually there's challenges to come. And I know that this year you were at the White House Summit looking at energy, net zero, the grid, and it was stated in the sort of opening address that actually this year the US is going to be generating more capacity than in the last 2 decades. What role does conductors have when we are looking forward to this huge amount of extra energy that's going to need to come through the system?
Yeah, when we think about climate change and the need for energy transition, electrification of everything, no matter what form of generation you use, it could be solar, could be wind, could be nuclear, could be hydro. On the consumption side, they're in the cities, they're in the factories, they're the homes, right? The electron moves from the generation to the consumption side in the wires or in the conductor. And the most critical limiting factor in the grid in terms of having enough capacity is the conductor itself. And that's how important it is in terms of accommodating what you just said. The U.S. is very ambitious. They passed several laws recently to really rejuvenate this area and also accelerate energy transition. Conductor plays a central role in that.
And I think it's, really helpful to picture what a conductor's role is when it's this kind of traffic jam of energy that is coming. And at Innovation Day here in London, you are showcasing something. It is the smart conductor. What are you showing off today?
Yeah, we are actually doing the world debut of smart conductor. The conductor itself can measure its temperature and can also measure its line sag. That allows the utility to have real-time information how the conductors or the circuit is sagging and whether they are able to push more electrons beyond what they have rated the conductor or circuit at, and basically will create more capacity for the grid without costing anything. And on top of that, it also allows the utility to have a much better handle in terms of extreme weather situation and their impact to the grid. If you have ice building on the conductor, if you have strong wind blowing at the conductor, you know which segment of the circuit are affected. You can know that from the control room. And if you have, let's say, maintenance issues, in the US, occasionally there are some crazy people shooting at the wires as target practice. So you may have some conductors damaged. It's going to create a hotspot. And if you don't solve that issue, it could manifest into a broken conductor and then causing fires. So with this technology, though, you will be able to know that from the control room as it happens, and you dispatch people to the exact location, get it fixed without any further issues.
The energy transition is like a metro network in a major city. It needs constant maintenance and optimizing as it fluctuates with user demand. Innovation across every piece of the machine is critical to make it function as it needs to. Without innovation, in every corner of the clean energy system, achieving net zero goals will be very difficult. Thanks so much for joining us on this episode. I'm Carolyn Kassan with my co-host Laura Young. For more information, head over to nationalgrid.com/podcasts. We'll be back next month with another episode, so make sure you're subscribed so you don't miss it.